Good afternoon. So, who would like to reduce their cloud spend while maintaining or even enhancing the value of your services? Can I see a raise of hands, please? That's great. You are in the right session. Thanks for coming along. So, most of you here might already be running on AWS or looking to start your journey on AWS. No matter where you are on your AWS journey, cost optimization is key for business value realization. In this session, I'll talk you through a few of the methods which you could leverage to optimize your cloud cost. And Ocado Technology will take us through their cost optimization journey and also learnings from them. I am Imran Dawood, Principal Solution Architect at AWS. And I'm privileged to have Kevin McCormack, Associate Engineering Director from Ocado Technology, here with us today. In terms of the agenda, I'll take you through the visibility journey. It's a process that helps us to mature our optimization program by gaining insights at multiple stages within our cloud journey, ultimately leading to optimization. Followed by, we'll go through those optimization methods, which will provide you an optimization success. Later, you'll hear from Ocado on how they leverage those optimization methods. And finally, I'll touch upon a key feature which you could leverage to start your optimization journey as well. In a typical cloud journey, you begin to build applications, or you lift and shift and migrate your applications. At this stage, you could see a sense of chaos because you're trying to figure out what applications to migrate, what tools to use, and how to migrate them. But as your organization slowly matures over the stage, it goes to an awareness where you build subject matter expertise within your organization and you start running production workloads on your cloud environment. As you get more and more of your environments running in the cloud, you start to get to a place where it's difficult to scale the safeguards that you have put in place to operate your workloads on the cloud. Because you need to look at policy management, you need to look at IAM access, you need to go through a security reviews which you have put in place within your organization. You might take a pause here, but you might take a pause here because of the complexity involved of the guardrail, because you need to make sure your workloads are satisfying the guardrails which you have put in place so that it can operate securely on the cloud. But most of you probably know here, it's important not to slow down because of those guardrails, but you need to travel along with them at a faster pace. That's where it leads us to governance. This is where we define our tagging strategy, account naming conventions, and maybe building a FinOps practices, and also what technologies to use on the cloud. And lastly, you look at the optimization. The reason why we have optimization at the end is you need to know who runs the specific workload, and have you actually defined the tagging in the first place, and what is those applications? Are they production or non-production? So this kind of makes it difficult to a state of running an optimization program across your organization without all the other steps which I have mentioned earlier. AWS have been building services and features over the years so that these optimizations which we talk about can be brought up a little bit earlier in your journey. So you don't have to have the full run state of operations of cloud or of FinOps before you can start your optimization journey. So what are those optimization methods which can help you to reduce your cloud cost without impacting your business value of your resources? The first thing we will look at is discounts. So within discounts, there are multiple levers you can pull, which is savings plan and reserved instances. This is a sort of discount model that helps you reduce your cloud cost associated to individual resources. If you have a stateless or a fault-tolerant workload, you could also leverage spot instances, which you could provide further cost reduction on your EC2 instances. Second one, deleting. We all remember that sometimes we create resources and sometimes people forget to delete them. So you need to find out those resources and delete them so that you don't get unexpected cost. So you could leverage tools like AWS Trusted Advisor or AWS Resource Manager to find those resources which has been laying around, which is not providing any value to the business itself. Third one is right sizing. So when we define a workload, we always choose an instance type that is apt for our workload. But how often do we revisit whether the size which we have selected for that workload is the right size? Are we leveraging autoscaling so that our workload can scale in and out based on the demand? So this is where you would leverage AWS Autoscaling to scale your resources as required, and AWS Compute Optimizer to provide you recommendation of what type of instance do you need to use. Are you using the latest version of instance type? Or for example, are you using Graviton, which provides better price performance for your workload? The fourth one is hibernating. This is all about shutting down your instances when it is not primarily being used. So you could relate this with your non-production workload, where you would mostly use it during office hours. On the non-office hours, if it is not required, you need to get them shut it down when it is not used. So what tools you could leverage here? So you could primarily use AWS Instance Scheduler to automate so that these can be shut down when they are really not in use. So we took at the 4 methods and some of the tools that could help you to automate them as well. So let's take an example. Let's take an AWS bill. This is an AWS bill before an optimization. Let's go through these methods to see how this reflects if we apply these recommendations on an AWS bill. So if you apply the discounts on this AWS bill, the savings plan and reserved instance, on average, you could get 30% discount on your existing on-demand instance and on-demand resources which you have been already using it. Next, if you apply the right sizing recommendation here, where you could auto scale your resources, okay, you could leverage the AWS Compute Optimizer to understand what is the actual instance type that is required for your workload. Once you identify that, then this could provide you around 20% of savings. So one thing which you notice here is, once you do the right sizing, then you can apply discounts on top of that instance. So ideally what you're doing is you're adding up these 2 recommendations, which will provide you around 50% of savings. Third one is hibernating. Mentioned earlier that those resources which are not being used in a non-production environment, or even in a production environment when the business is not using it, then you would leverage AWS Instance Scheduler to shut down those instances. That could provide you 20% of discount. Lastly, those unloved leftover instances, leftover resources which you are not using, if you delete them, that will give you a 5% of savings. So if you add all of them up, you could potentially get 65% of savings on your AWS bill. But wait, if you actually add all of them, you actually get 75% of savings. But the reason I have put up as 65% is you don't necessarily add all of these methods together, because some of those methods could overlap. For example, if you have deleted some of the resources, you won't be right sizing them, or you won't be hibernating them. So some of them do overlap. So potentially you would only need to pay 35% of that actual bill which you have in the initial phase. So that's why it's really important that you leverage these methods to see how optimized your workload can be. Let's take another example. Let's take an EC2 instance itself and then see how we can apply these methods to see their potential savings. So this is a chart which is explaining about the usage of an M5 4XL large instance, which is costing us around $660 per month. If you look at the utilization, this instance is being utilized max to 25%, and primarily it's being utilized from 6 a.m. to 9 p.m. So let's apply the methods which we talked about. So one thing you noticed here is this instance is over provisioned. So if you right size the instance, you would potentially get $520 of saving, and you would be running on an M5XL instance, which would cost $140 per month. Okay? Next, what else we can do? So if you look at the next one, this instance is being used only between 6 a.m. to 9 a.m. I talked about AWS Instance Scheduler, which you can use to schedule your instance to shut down when it is not being used. So if you shut down the instances when it is not being used, you could potentially get $52 per month of savings. So which would mean this M5XL large instance, you would be paying only $88 per month. So from the time you are paying $660 per month, after applying the discounts, you would actually paying only $88 per month, 86% of total savings. Let's take another example to see if we can use some of the other methods as well in this example. So same M4XL instance, $66 per month, it's over provision, so you go ahead and resize it, $520 of saving. So now what we can do, so previously we shut down the instances when it is not being used. What if you apply the reserved instance or savings plans on this? So if you apply reserved instance or savings plans, you would again achieve $52 per month of savings by applying that savings, which eventually gets your M5XL to $88 per month, 86% of total savings. So if you look at it, both the examples provided a similar savings. So as an organization, you need to pick and choose which method would work for you and which method will give you the best savings for your workload. So that's the key decision which you need to take. I'll bring in another example. So this is an workload utilization chart. So if you look at it, the blue chart indicates, the blue bars indicates the steady state of the workload. So when your workload is steady, that's the constant usage of your workload by your customers. So that's where you apply the reserved instances and savings plans. And for example, if you suddenly your workload utilization increase, for example, it could be an event, for example, a Black Friday event where your consumers are actually accessing your application, so your workload cost is increasing and it needs more resources. So this is where you would leveraging the right sizing recommendations of leveraging autoscaling to autoscale some on-demand resources so that you can manage those spike in users. So there is another scenario where if your workload supports, for example, stateless or a fault-tolerant workload, then ideally you could leverage spot instances. So spot instances provides up to 90% of savings on your on-demand price, but only caveat is the EC2 instance will provide you 2 minutes warning before it can take back the resources. So you need to really architect your application accordingly if you're going to leverage the spot instances. So I've covered the 4 different methods here. So I would recommend you to take a photo of this so that you can take away a few of the resources which I have mentioned here, which will help you to optimize cost. So now we have covered those 4 methods. I would like to invite Kevin onto the stage, who is the wizard of cost optimization from Ocado Technologies. Please welcome to the stage.
Thank you. Hey everyone, have to be really careful getting up because they've cost optimized the stage here. There's only stairs on one side and not on the other. So as Imran said, I'm Kevin. I'm Associate Engineering Director at Ocado Technology. So Imran has gone through some of the theory on cloud cost optimization, but I'm here today to share with you our story, our journey on how we're able to save millions of pounds on our AWS bill without compromising on either customer experience or slowing our rate of innovation. Now, I'm going to talk about some of the engineering changes we made for the technical people in the audience, and they are really important and critical. But also, actually, I think the secret of our success is actually slightly more on the organizational side. So we're going to talk about how we motivated our large community of developers and motivate them to actually do some of this cost reduction work without compromising on feature delivery. So firstly, a little bit about Ocado. So Ocado Group began as a pioneer in the online grocery market 20 years ago, and we continue to be pioneers to this day. Our mission is changing the way the world shops for good, and in order to achieve that mission, we created OSP, Ocado Smart Platform. Now, OSP is the most advanced e-commerce, logistics, and fulfillment platform for groceries in the world. It leverages advanced technologies such as data science, robotics, machine learning, and it's built for the cloud and uses a microservices architecture. Now, for example, in our e-commerce solution, just to show how we use some of those technologies, we have a feature called Smart Shop that basically looks at your historical buying habits and uses time series analysis to work out the cadence at which you buy certain products, and therefore is able to predict what you want in your basket at any moment in time. So we can actually do your weekly shop. You can do your weekly shop with just one click with Ocado. So just calling back to the keynote that we saw with Zilch, where they actually aspire to be able to do this, we're actually able to do this at the moment, right? And in the last mile, our software carefully considers delivery slot windows, product type, product weight, in order to optimize every van. And we're able to can factor in vehicle loads, traffic conditions, fuel levels, things like that, in order to optimize all our routes for home delivery, so make sure that people get their shopping on time. So all of these advanced features rely on pretty important cloud services, and none of this is cheap, right? You guys know this. So this means that AWS costs are one of the principal costs of running our business. During the lifetime of OSP, we've kept an eye on these AWS costs, but actually we've concentrated on delivering the features that our partners have been asking for and that we think are really important for us to run their business. And you can see the success of that approach by the map behind me here. So the countries that are in blue are where we have a partner that's using OSP. And we actually have 13 of the most innovative grocery retailers in the world using our platform. We actually have a number of different AWS environments to serve those 13 partners. Some of these are e-commerce, like customer-facing environments, and others are used to power our automated CFCs, or customer fulfillment centers, which is basically what we call our warehouses. So back to the cloud optimization story. So by the end of 2022, we'd achieved a level of data maturity where we had one data set which was all of our business metrics about running our business, and another data set which was our AWS costs. And we were actually able to mash those two data sets together in order to gain some insight into how our AWS costs changed as our business metrics changed. We used some historical data to model how our AWS costs changed as our orders flowed through our various OSP instances around the world. And we created a model which is basically that blue line that you see on the graph there. And it may not sound cool, but it was really important to us. We were able to predict what our AWS costs would do in the future as order volume changed through our systems. But actually, we wanted to go a step further. We wanted to actually reduce our cloud costs, and we felt that this might actually be able to help us. So we got some insight from engineering into what the art of the possible may be on cloud cost reduction. And we also got some input from the business on where they wanted our cloud costs to go in the short, medium, and long term. And so putting those inputs together, we're actually able to construct a second model, which was where we wanted our cloud costs to be at the end of 2023, which is the green line you can see on there. So it's just two lines on a graph, but actually that green line was a really aggressive target. It's a really significant reduction, and it was a big deal. But actually, only a handful of people had actually worked on this. Like, a few people analyzing the data, talking about what the art of the possible might be, setting targets. We've got 2,000 developers in our organization. How do we get them on board with this? So we decided to adopt this target, this green line, as one of our organizational goals for 2023, for last year. So we typically set about 5 goals a year, and we talk quite a lot about them. They're pretty important. We talk to everyone about how they're being measured, and we measure the progress against them. In this case, we decided we were going to keep things simple and measure just in 2 environments. One customer-facing e-commerce environment, and one CFC, or Customer Fulfillment Center, AWS environment. Now, once the goal was set, there was actually quite a lot of excitement around it. Like, people realized that these are really big targets that we're setting, and this is a big challenge. And actually, we all know that engineers really love a challenge, so this was really cool. To build on that excitement, we actually had a dashboard available from day one, which actually showed what progress we were making against that goal. And people were able to consult that over the year to see how we got closer. Now, we actually took this wide organizational goal on target, and we actually split it into sub-areas. So each of the main areas of OSP, which are e-commerce, logistics, and fulfillment/ASRS, they got their own kind of sub-goal. And they were responsible, so we assigned the goal based on kind of what we felt was fair, based on previous load profiles and things like that. And each of these areas had responsibility for their own goal. They are autonomous areas, and they're able to do whatever they felt was necessary to achieve the goal. And each of these areas was strategic about the work they did to achieve the goal. So, for example, in one area, maybe one team is working on some really important innovative feature work and just has no bandwidth for cost reduction, but maybe there's another team that actually has bandwidth to do a bit more than the average cost reduction. And so in those cases, like the organizational units, the areas can actually be flexible about how we do the work. So our FinOps reporting helped us as an organization be really clever about how we invest our time. So we actually ingress the data from our AWS bill, our itemized AWS bill, and we have proprietary software that allows us to allocate cost of shared resources, such as an ECS cluster or an OpenSearch cluster, to individual apps that are using it. We also, for a number of years, have had quite a strict tagging policy in place, which means that any resources that are directly used by an app must have a tag on them that identifies the app ID. And so between those 2 things, the kind of proprietary software for allocating shared cost and the tagging for each app, between those 2 things, we're actually able to give developers insight into, by app, by environment, exactly what their AWS costs were, which products they're using, and what the cost was. And this way, a team can see exactly where their cost is going. They can address the biggest cost or the most achievable cost reduction. And we all know that measuring is important, right? In order to see the effect of something you've done, you have to know what it was before, you have to measure it before, you have to do it, and then you have to measure afterwards. We also found that actually, like, kind of sharing success and gamification to a certain extent actually really help people with this task. We created a cost-saving success stories like channel in our internal Slack, and people shared their experiences there, what they've been able to do, how they've done it. They shared their learnings, but also they shared what they thought the annual cost savings were from each thing that they did, and that was really motivating. Also, we had an ongoing running total of actually how much savings we've made over the year, and that ran into millions of pounds. So I've talked quite a bit about some of the organizational aspects, and maybe some of the engineers in the audience are going, when is he going to talk about some actual engineering changes? Well, that's the next slide. So I'm going to start with autoscaling. So we've long had policies in place, especially in our e-commerce customer-facing environments, to be able to scale up and down with demand. But typically these were actually step scaling policies, which is kind of like an older type of auto-scaling policy. And actually, through experience, we found these to be quite hard to optimize. So our auto-scaling policies need to work in our highest load environment, which is typically our load test, right? And it needs to work all the way through multiple different environments to our lowest load production environment. Same policy needs to do all the work. And we just found that we needed a lot of engineering effort to make that work with step scaling. On the graph you can see here, this was one of our apps that we actually improved. So, and this app started with step scaling. We actually continued with step scaling in this case. You can see it's a critical service. And so we've got 28 instances at the start. And we've been very conservative with this, again, critical service. But the team in question, they actually persisted with step scaling, and they came up with an improved policy that was able to handle the various different environments that we've got. And you can see that actually it's pretty clear when they introduced that policy, and you can see that it's able to scale up and down really well. The second graph that I'm going to show here is actually a different app, and in this case it was using step scaling originally, and we actually moved it to target tracking. So many of the auto-scaling policies we put in place actually use target tracking. So we find it's a lot easier as a developer to do target tracking than step scaling. You just define the metric that you want to measure and you define the values, and AWS does a bit more for you. And everyone loves it when AWS does more for us for the same money, basically. And so, yeah, in this case, this was pretty successful as well. So improving our auto-scaling was like a massive opportunity for us. You can see the differences in like the first graph and the second graph on where we were and how we were now. It's like a really big cost-saving opportunity when you look at it like this. But this is just one environment. When you have this multiplicative effect or multiplying effect of actually, this is just two of our microservices. We have loads of microservices and we have loads of environments. So you can quickly see how this adds up. Also, it's kind of like, it makes a big difference as well for our customers, right? So we can be more confident in our scaling policies. We know that we're going to handle higher load, and we know that our systems are going to react. It's good for customer experience as well. So, instance sizing. So in some cases, once the teams had addressed auto-scaling, they moved on to looking at instance sizing. And my personal feeling is that actually auto-scaling is easier to address. But we're going to talk a bit about instance sizing as well. So there's actually really two scenarios here. The first scenario is when you're able to actually change the CPU and memory requirements for your app without actually even touching the app. So sometimes developers are conservative when setting policies. We've seen this for various reasons, but maybe you're putting a new application into production. You've got enough to worry about without worrying about running out of memory or the app running too slow. Or you're migrating. One of the cases we have is where you're migrating from on-premise and you just want the thing to work, right? You're just going to give it all the CPU and memory you think it's going to need. But actually, once an app has been stable in production for a while, actually maybe you can go back and look at those things, and that's one of the activities that we did. The second one is a bit more complicated. It's when you actually have to make changes to the app itself in order to be able to reduce the CPU and memory requirements. So we've actually seen some success there with Java 21. Moving to Java 21 is not a code change in the app, but it is a change in the container. And we've actually seen that we're able to reduce the CPU requirements because it's more efficient at startup time. Another example that we have is when we were using a caching library. So sometimes you do actually have to change the libraries, and sometimes you can be more efficient there. So we had a caching library that we were using, and we were actually able to remove that caching library because we realized that it was a premature optimization that someone had introduced that actually was causing extremely high memory requirements on an app that actually wasn't needed. We actually ripped it out, reduced the memory requirements, and the response time went from 2 milliseconds to 4 milliseconds, which was fine in this case because we're using DynamoDB behind the scenes. So next, I'm going to talk about RDS and Graviton. Right, so many of our services use databases, and quite a lot of those use RDS Postgres, right? And so we actually took a 3-stage approach with RDS. So we were able to first ask the teams to review their instance sizes. So it's a relatively easy activity. You go in, you look at the CloudWatch metrics, you look at it over time, and you see, are we like underutilizing these instances? So if you're able to do that, often you can make some significant reductions there. Secondly, we actually switched all our instances to Graviton, which is the kind of graph you can see at the top here. So Graviton is like around 10% cheaper than x86 instances. And we have hundreds of instances, so that's like a really important saving. And we're actually able to migrate those in a fairly automated, centralized way using our internal platform. And so you can see the kind of, hopefully it's relatively clear, the graph has a blue line at the bottom, which is the Graviton T4G instances. They gradually consume all of the T3s that are there over time, and you can see at the top there's a line of M5s that are consumed by M6G. Now, the third stage is that once we've done instance optimization, moved to Graviton, then we were much happier buying some reserved instances. So we committed to some one-year reserved instances, because you need to kind of be comfortable with that. You need to know you're not going to change the instance type, and you need to know that you're buying the right amount. And so we're able to achieve about a 1/3 saving using reserved instances as well. So when you add up the instance size optimization, then the Graviton switch, then the reserved instances, you can see that actually that's a really important saving. Just the second graph here is just our reserved instance coverage, right? So we aimed to get to around 80% coverage, and that's pretty much what we achieved. So Spot, right? We're really big fans of Spot, both for the kind of cost savings that we get from our Spot instances, but we'll also like see some other benefits as well, right? So we use Spot instances significantly in our ECS clusters, in our customer-facing environments, in our e-commerce environments, where all our microservices are multi-instance, and all of them are able to tolerate the situation in which a Spot node goes down and the app instance gets stopped. We benefit from this really significant cost reduction, but also we see the benefit in resilience. So when these apps are used to instances being added and removed, app instances being started and stopped, the app itself essentially is getting constantly resilience tested, and we see some significant benefits of that. In our CFC environments, many of those apps were actually on-premise to start with, and we moved them to the cloud, and we moved them straight into ECS clusters with on-demand compute, because, again, migrations are hard. You just want to keep your life easy, and that was the most equivalent thing to the on-premise servers we used before. But actually, like, as part of this cost reduction effort, we realized that many of those apps could also run on Spot. They're multi-instance, and they could benefit from the extra resiliency testing. So this graph is from one of our apps that we moved, and you can see that, like, from the start, you can see the moment, like, the 7th of March, where we moved it to Spot, and our compute cost dropped massively. And then you can see, actually, over time, the team made some other optimizations to further reduce the cost of the app. But you can see Spot, really good. So logging. During 2023, we actually moved from managing and owning, running our own ELK clusters to using AWS OpenSearch. So this was a step change for us in terms of management. It's a lot easier to manage, but also we got some cost benefits from it as well. As I mentioned before, we are able to assign the cost of these OpenSearch clusters per app. So, and it's based on the log lines that each app generates. So an app that generates 10% of the log lines will get assigned 10% of the OpenSearch cost. This incentivizes our developers to reduce their logging. And we can see two main ways of doing that. The first is to just log less, either just by removing lines of logging from your app, or by changing the verbosity from like debug to info or whatever. And the second one is you can actually log more on one line as well. So in some cases, we just combine log lines together. So you're generating, instead what was 5 different debug statements before, maybe is now 1. We have fairly short retention periods in our OpenSearch clusters, and we actually made those even shorter. So we kind of have to be careful around being quick to retrieve logs after we've had a production incident, because they will be gone. And I should say as well on the logging, it's like you have to be really careful to balance. If you're going to remove log lines or if you're going to change your log level, you just have to be careful that those logs are there for a reason generally, and you need to be able to diagnose your production incidents. So there's no point in having almost no logs and then not being able to work out what's gone wrong when you have an incident. I actually think this graph is really interesting just generally, right? It shows just one of our apps. And it shows how you can see at the start that the compute cost was about 3 times the logging cost initially. And so around, I think it was around mid-March, whenever it was, the compute cost was like dramatically reduced. I think this was an auto-scaling policy change. And you can see that actually, so now looking at the graph, the team can be strategic and say, actually, well, now compute is sorted out. What's our next biggest cost? Well, our next biggest cost is logging. So you can see towards the end of the period, actually took some actions to reduce their log cost as well, using some of the techniques I've already described, and they got the log cost down. So you can see the difference in the cost of this app from the start to the end of the period in question is really important. Right, sharing more. So when we started developing OSP, we had a sort of pattern of one load balancer per microservice. And now we have a lot of microservices. So that's a lot of load balancers, and that's a really big cost reduction opportunity. So we actually introduced the possibility of using a shared load balancer, and some of our apps have started using that already. It's still an ongoing journey, but we have about 25% reduction in our ALV bill just by using this shared load balancer, and we think there's some way to go there as well. And similarly, we have Kinesis data streams in each app, which are used to send events to our data lake. Again, one of these per app, and actually we're moving to a more centralized model where you share a Kinesis data stream. And we think that's going to give us around 65% cost reduction, but we also think it's going to be helpful for our developers in that they're going to have to manage less things, right? So there's a kind of saving on the burden there for developers. And then the final thing is like combining microservices. We have a microservices model, and any of you who've used it will know that it's quite difficult to get things right in terms of having, like, assigning responsibilities to services, but not going too fine-grained. And sometimes you can get that wrong. It's not always easy to get it right. And even if you get it right, it may not continue to be right because things change in your systems, right? So we've been asking ourselves some of these questions this year. Have we created too many microservices? Can we optimize? Can we condense them together? And we've actually seen some areas in which a team owns multiple microservices and they've been able to reduce and condense them together, consolidate them together, sorry. And obviously that has clear benefits because every microservice instance has a fixed cost. You need a minimum number of instances, you need shared resources such as databases and things like that. You can make significant savings by combining. So the kind of $1 million question or multi-million-dollar question really is like, how did we do? Well, this graph shows the green line is the target, the blue line is our actual, and you can see just right at the end of December, we actually managed to get below the target for the first time. So we're really happy. I mean, this is like, it's hard to sort of say, but you can see it on the graph here. Like, it's a massive saving that we've been able to make millions of dollars, or pounds or whatever. And we've got really good return on investment for the time we've employed. And there was a real feel-good factor about doing this work. People really got behind it, realized it was important, and like really got stuck into it. And I guess like just on this, like in the keynote we heard some discussion about sustainability and things like that. Like one of the forgotten things about this is if you're using much less compute, then actually this is really important sustainability message, right? It's great to be saving costs, but it's also great to be saving the environment as well. So I just wanted to sort of touch a little bit on innovation. So we're really proud of our record of innovation. We talk a lot about our bots and stuff like that. You can see in the video our 600 series bot and our OGRP, our on-grid robotic pick arm. And these are hardware innovations that are really important. But what's a bit less easy to see is there are also really important software innovations ongoing at the moment. We've got something we call Swift Router, which is an optimization solution that allows short and long lead time orders to be combined on the same van. That's just really important for our business. and we just can't afford to not be working on those things. So this cost optimization that we did, we performed it strategically in teams that actually had the bandwidth to do the work. And we typically did this with time that would be used for engineering optimizations. So we didn't affect any of our feature delivery or innovation by doing this work. You also see that many of the changes that I've described have a positive impact on customer experience. We've talked about better auto-scaling, reducing response times, things like that. So what did we learn, and what are the important things that I think it's worth sharing from our story? Well, it's really important to start with the data to be able to measure, understand where you are. So just use whatever tooling you can, but build a view of how your AWS costs change with your business metrics. Then give developers visibility. Like they really need to see an accurate view of what their costs are and how they're able to change them. So once they see and once they can measure, you actually be surprised at how much developers are able to do with not actually that much extra time. And setting an organizational target works really well for us. I don't know how many software engineers there are in the audience, but if I asked you, I imagine many of you could probably quickly say 2 or 3 things that you could do to reduce cost right now. But it's about kind of coordinating and getting that organizational momentum behind doing those things and actually getting the sort of bandwidth to be able to do it. So I think that's really important. So just from there, thanks for listening. I hope you found it interesting, and I'm going to hand it back to Imran now.
So thanks for sharing those methods and insights, Kevin. So I'm completely gobsmacked that you are able to save millions of pounds just by defining an organization target and successfully driving this cost optimization program. So massive effort by everyone at Ocado Technologies. So if you remember, one key thing out of this session is how much each application would cost them, that visibility they were able to obtain. And this is primarily possible, if you look at it, it's because they had a strict tagging policy. And this was enforced via automation and also while creating resources using automation. So what could you take or what could you do in your cost optimization journey? So one key feature I would recommend you to check out is Cost Optimization Hub. So this makes it easy for you to identify, filter, aggregate, and quantify the savings for AWS cost optimization recommendations. So if you look at it, this is a single view which provides you all the different methods which I mentioned earlier, the recommendations, unused ideal resources, moving to Graviton, moving to new resource types to save cost as well. So, and one other thing is, it will also highlight how much you could potentially save if you actually implement those recommendations provided by Cost Optimization Hub. So with that, recap, discounts, please leverage savings plan, reserved instances, spot if your application supports, delete those unwanted resources, right size your instances, and hibernate those instances or shut down when they are not used. And lastly, from Ocado, start with the good data, set an organization target, and give everyone the visibility of their AWS spend so everyone can take that initiative to optimize at their end. And lastly, please look at Cost Optimization Hub. And if you'd like to learn more, please visit skillbuilder.aws. And final request, please scan this QR code and provide your feedback so that we can continue improving our content. Thank you very much for listening.